So we're going to start kind of hardcore into ice tables today, and we kind of touched on them a little bit up to this point, but okay, hands. Thank you. All right, but we're going to actually get into them much more in detail today and try to figure out like which way things run and all that good stuff. So when you're given the K value for a particular temperature, remember K can change by temperature. We're going to talk about more with that in terms of how that happens when we get into, I think it's 7-9. But we can figure out we can determine the concentrations of products or reactants for a reaction at equilibrium based on those initial values if we have our K. So essentially, it's stoichiometry all over again, okay? But it just doesn't go to completion because, you know, it's going to eventually turn back the other way and goes back and forth. So that's the idea of it being a forward reaction and a backward or reverse reaction. So you have to figure out which one is going to be favored. One way to approach those again is with these ICE tables, initial change equilibrium. Sometimes you'll even see them called RICE tables, and the R stands for reaction, initial change equilibrium. So if we're given this reaction here, okay, and they're telling us that we have an initial concentration of A and B, that's 1 molar. When we are done, our C is at 0.12, okay? They want to know what is the value for Kc. So we know that here that we changed this by adding in plus 0.120 molar. We didn't start with any of this, okay? If we take this up into the cloud, what do we have to do?
Divide by 4.
Divide by 4. So 12 divided by 4 is going to be 0.03. So then when we come back down out of the cloud, we have to multiply. So here we're going to multiply by this, and we know that this one's going to go away or be reduced because we didn't start with any of this. So of course, this we would have to take from here to make this. And then this is going to be minus 0.03. So then this will end up being 0.97 at equilibrium. This guy will be 0.94. Oh. Yeah, 94. That doesn't look like a very good 4. I'm sorry. Let me try that again. There. All right. So we have that taken care of for our RICE table. Now they want us to calculate K. So we can plug that stuff into the equilibrium constant. So Kc is going to equal our products, which are here. And what do we have to raise that to?
4.
Yep. Divided by this guy, 0.97, times 0.94. And what do I have to do to him? Square it. Yep. Okay.
Square it.
Two for the B.
Your mom? Your dad? What?
Ew, please stop. It is 4 to 2B. You guys are inappropriate. We are in class.
Do you need me to show you how to put it in your calculator? Is that what you were asking? Well, I thought she said, how do you square it?
Well, I think we're all
That's
like
why.
You can say why do you square?
Oh, why? Okay, I'm sorry. When you guys are clucking over there, it's sometimes hard to hear who's talking. Okay, why do we square it? We square it because the coefficient here is a 2. Just like this one was a 4, so we raise this to the 4th power.
Why do you put it in that fraction thing?
This?
Yeah.
Because that's how we figure out our... Hey, hands, hush. That's how we figure out our K value. That's,
Oh, so it's just a formula.
yeah, it's right here. Yep.
So, okay, I understand.
All right, so then once you're done with that, if you throw that into your calculator, and make sure when you go down under the bottom line down here, that before you start down there, that you have to put this guy in parentheses here. Okay? Okay? Oh, it's not going to let me do it.
Banana's so far away.
So this whole thing down here in your calculator needs to be in parentheses before you do that calculation. So put this in, do your caret. So 0.120, hit that caret key and hit the 4. Then you're going to hit divide, then your parentheses. Then you put these things in your parentheses and hit equals.
Why don't you put the top in parentheses?
Why don't you?
Yeah.
Because it's already on the top line. You don't need to tell it to go there. All right, so if you put that in your calculator, you should end up with 2.42 tens to the minus 4.
Oh my gosh, I got this.
Good.
Oh my goodness, look, we don't all need to hear about your lunch plan.
And don't listen.
All right,
Don't
our next one that we're going through, they are giving us initial amounts, and they didn't tell us anything about AB, so we're going to assume that that is 0, because they didn't say anything about it. So that guy's going to be 0.
What? We're changing it now?
No, we're on a new problem.
Equilibrium. Where is it?
Next page, Evie, flip it.
I wrote it in pen.
What did that hit my eye? Do you ever think about that? That your actions could have consequences? Well, I was trying to do it, and then mine came out. That would have been embarrassing.
All right. So we're using these ice tables to solve this guy. We have an equilibrium constant. We know that we started with 1 mole of this and 2 moles of this, and that they're getting to equilibrium. Okay? We know that we don't have any of this, so we've got to be making this. So we're going to be adding x here, and we're going to be subtracting x here.
Oh my God. What was that?
Okay? So then at equilibrium, this is going to be 1 minus x. This will be 2 minus x, and this will be x. Okay, now they told us that our K value was this guy. So we know that 3.4 times 10 to the minus 3 is going to equal x over 1 minus x times 2 minus x.
Algebra.
Okay, now.
No, that's so embarrassing. Don't even. What is it?
That's embarrassing.
Listen to me.
Where's being rude looking?
Listen. On the AP exam, they will never give you a problem that you have to use the quadratic equation for.
Never. Wait.
Equals negative b plus or minus square.
Is that the quadratic?
Wait, so is that what you'd have to use?
Yes. Okay.
How do you use the quadratic formula again?
Imagine them assuming that you're just good at math.
Okay. Now, there will probably be a few homework problems where you do. I do have on my calculator, and I can try to transfer it over to yours, a quadratic program on here, where all you have to do is type in the value for A, B, and C, and it will give you the answer.
What's A, B, and C on there? Yeah, which one's A and which one's B? Which one's
A.
A is the one that's going to end up being squared, and then you'll have a plus or minus something
no,
x.
like,
So this will be your A, this will be your B, and then you'll have a plus or minus C. Right? Whatever is multiplied by the squared thing, what is multiplied by the x, and then whatever is by itself.
AX plus EX.
Oh.
They are confused. So I don't know. No. That's for math. That's for algebra stuff.
Well, yeah, no, but like,
But your
she said we're
question-
having to use the quadratic formula. Which one is the A and which one is
No,
the B?
she said that we don't have to use a quadratic.
But she said in the homework we will,
So,
so I just
okay,
need to know
so
how to do it.
when you do a quadratic, right? When you have a quadratic, you have A times x squared. So there's a number here,
Oh.
whatever value that number is, plus or minus B, which is some number times x, okay? Plus or minus, and then some number, okay? And you have all of that set up equal to C. My quadratic program on my TI calculator, all you have to do is type in this value, type in, if it's a minus here, you would type in negative, whatever that value is, and then a negative or positive, whatever that value is. Hit the key, and it'll give you, like, when you solve a quadratic, there's typically two answers.
Yes.
Okay?
Oh, yeah.
So you'll solve for that. And then whichever one makes logical sense, and we'll talk about that in a minute, is the one you go with. Okay?
What's that key?
What do you mean by key?
She said she has to transfer it to yours.
Yeah, we don't have that.
You may have it from another class. I don't know. But I have a jump cable in here. I can try to transfer it over to your phone because it's going to be handy for math, if nothing else. I'll look for it later. All right.
I can't wait to get my.
So the other thing is that we have a rule that we can eliminate x. Okay? So certain times you can ignore or eliminate x. And what that...
She's explaining.
Okay, do you see the x here? Do you see the x here? Okay. In some cases, you can ignore that x. And when you can eliminate or ignore it is when your initial concentration divided by K, if that is greater than 100, you can eliminate x. Okay, so my initial was 1. So 1 divided by 3.4 to the negative 3 is 294.
Wait, so you just, okay, yeah.
So I take my initial amount, whatever my initial amount was, that's going to go on the top, and I'm going to divide it by K. So 1 over this value equals 294.
No X's.
Okay, so I can eliminate that value, but on the AP exam, you have to denote that. Okay, and the way you do that is you simply draw a line here and just say that you know that you can ignore it. Okay, that's enough documentation for this. What?
What do you do if it isn't over 100?
Then we're going to talk about situations where we come into that, okay?
But that won't be like that on our homework.
It may be on your homework, yes, where you can't ignore it. Okay, but then you can solve with the quadratic.
Okay.
And you guys know how to solve with a quadratic. I mean, it's not like you haven't done that enough times in your life. You can also, I'm sure on Google probably call up a quadratic. Yeah, here. All you have to do is just go to a website. All I did was type in quadratic formula calculator. Okay. All you have to do is type in the A, the B, and the C. You're not going to have one of these on a test or a quiz where you have to use the quadratic. So if you run into that on the homework, just call this up and use it. Okay. And I'll throw it into this at the end and see if we come up with the same answer, but which you should, if you want me to rearrange all this crap. All right, so what that means is we can ignore these x's because if you, whatever we solve for x is going to be so small that it's not going to dent this 1 or dent this 2 enough to make a difference. Does that make sense?
Yeah.
It's not going to have enough impact on them to where we need to throw that into our calculation. So if I rewrite this, 3.4 times 10 to the minus 3 equals 1 times 2, because I'm ignoring these x's now. 1 times 2 is 2 over x. So x is going to equal 6.8 times 10 to the minus 3. So if I took 1 minus 6.8 to 10 to the minus 3, that's 0.9932. Okay? So 1 versus 0.9932, it's so little that it doesn't really impact your calculations enough. So x in the end here is going to equal this will end up equaling 0.0067 or 68, I guess it would be the way that rounded, sorry. This is going to be 2 minus that. So 2 minus 1.99. And then this guy will be 0.99. Okay, does that make sense?
Yep. I don't feel like running shoes. It's like a long or like black.
Or gym teacher.
I saw her do warm-ups today. I would not expect her to be a gym teacher.
I can just see her like running around. I feel like gym teachers just run around a lot.
No, they don't.
They just like randomly
Ruin on their own phone, ruin lives, get a microphone.
At
All I
my school,
want
they
is
were
to
like
be
never
my
in class.
bestie and Lilith, but no. You have to ask another gym teacher.
Are you being considered by Allie now?
No, I'm trying to cadet in her class. I'm trying to switch classes. So right now I cadet team sports. Right now, because I want to cadet core.
All right, so if I add x to this side, right, I'm going to end up with 3.4 times 10 to the minus 3x squared plus, I'm just showing you how that quadratic formula calculator works and comparing that to the answer we got up here where we ignored this. Okay? So I'm just trying to show, kind of do a proof here.
Yeah, I figured. I was just making sure I don't write down stuff I don't need to.
So minus 1. So this is going to be a negative, no, a positive, sorry, positive. .9898x and then plus 0.0068. All right, so now let's go over that quadratic formula calculator. I can find it here. There it is. Okay, and I'm going to punch in those numbers. So this is 3.4. Oh, it probably won't maybe due to the negative. So 0.1234, 0.9898, and 0.0068, and calculate. Cross our fingers. Okay, so there's the one answer. Okay, and here's the second, because you know when you do your quadratic, you come up with two answers. So do you see how by ignoring that x, it really didn't have any impact on our answer? We could go through the quadratic, but we're pretty much coming up with the exact same thing. Here is the other answer. Now, how do I know that this isn't a valid answer? Well, if I were to take negative 291 from this, that would make it would work. I didn't have that value amount. So one of these answers, when you solve for the quadratic, isn't going to make any kind of sense at all. This would not make any sense because you can't take that much away from one. We didn't start with that much. So that guy's gone. So that only means that one of these is a rational or clear answer. Okay? But we came up with the same amount. All right. So there is the assumption rule. All right. So is this where I deviate? Yes, this is where I start to deviate.
Oh my god. That's disgusting.
Yeah. Number 10 actually was good. And number 10 I still can't believe number 10 really thought that was a big comeback. What was the comeback? Oh.
All right. So we talked about. I don't care. Just go away. We talked about the forward and reverse reaction. We talked about K being temperature dependent.
Is this the second one? Would be the other.
Is this the next page? Or did I have another one that I needed to solve for? No, I did that. I finished that page. Aren't we on to this next page? Isn't this what your page looks like next?
No.
Oh, okay.
It looks like an I do.
Oh, is it an I do? Okay, maybe I was wrong. Maybe I didn't include it at the right spot. Okay. Is this it?
Yeah, that's
Okay. All right. Sorry.
It's okay. I just didn't know where this page was coming
Okay,
from.
I screwed up. Nothing new there.
Why are we being rude? If I would have said something, we went over stuff, but we didn't need to. I'm kidding.
All right. So here we reached a partial pressure of 2.45 in a previously evacuated vessel. After the reaction reached equilibrium, the pressures of I2 was 0.3. So we know that that is our equilibrium pressure of I2. We know that ICL, okay, so ICL, we started with 2.45 here, and we didn't have any of these.
So this is a reverse reaction? Oh my God.
Yep, they added the product.
I was just in shock. No.
All right. So if I made this much here, and these are in a 1-to-1 ratio, that means that I had to make the same amount of this. Okay. And then I added those in because I didn't start with anything, so I had to add them in. And that means that up in my cloud, I have 0.3. So then when I come down out of my cloud, how much would I have used here?
0.6.
0.6. So if I subtract this from this, I end up with 1.85.
When you do the equilibrium constant.
Yep. So now we're going to do the KC. Remember, your products are on top. So that's the 1.85. What do I have to do with that? Square it. And then these guys are going to be down at the bottom. So they're going to be 0.3 times 0.3. Okay, so when you calculate that out, you end up with 0.64. What are the units for KC?
I did not get that.
Isn't there no unit?
Oh, that's the wrong answer. I'm sorry. Hold on.
Thank you, Lord.
I was like 38.
Oh my God, we're way off. Oh my God, I messed up.
Oh, 38. Yep, 38. There you go. Better?
That was almost very concerning.
Okay. All right. Sorry. I was looking at another problem.
Which one do you call?
All right.
No problem.
Next one. We've got,
The answer.
what? 38 is the answer.
I thought we were like continuing.
No, they just wanted to know the equilibrium. And yes, you're correct. The K values, the equilibrium constants are unitless.
No. This is a big, important. This will go fast.
It is.
Why? Can you come on Friday now? Yes, here at home. It's very important.
And why is it important? I mean, first of all, I'll already be
The
there
number
on the
2
court.
seed.
Are we gonna win?
Yeah.
I'm not gonna come there if we're gonna
All right. So
win.
the reaction initially contains a partial pressure of NO2 of 0.1 atm. So that is our initial amount. Then when the reaction reaches equilibrium, the partial pressure of that is going to be 0.08. So they want to know what the concentrations on initial and equilibrium concentrations of N2O4 are. Okay. So in order to get here, what did I have to do?
No.
Minus 0.2.
O2.
Yeah. No, O2 is 0.98.
No.
Minus
Yes, it is. 1 minus. Yeah, so that's what I'm saying.
Oh, no. Oh, but it equals 98.
0.92.
0.92.
0.92.
At 0.92.
Duh.
1 minus 0.92.
You idiots. I was thinking of old. How could you ever do something wrong like this?
Oh, wait. Jaden thought 0.02.
No, it's not like that.
So we're gonna win, so that means we're number one.
Wait, no, that's no.
Because it equals
1 minus
0.82. You have-
0.92.
No, it is 0.02. You're right.
Wait, dumb.
No.
That's what I said. Jacob, you're dumb. Wait.
What? 0.92.
It can't be
Point. This is
Oh,
so
it's
fake.
0.1. Boy, hold on.
Yeah, it's 0.1.
Hold on. Yeah, it's 0.02.
0.1 minus 0.02.
I thought it was so good. I thought.
All right. I should have believed myself. I had that written down and I didn't believe myself. I listened to you guys.
I had more
All right. So this is 0.02.
You were not right.
Yes, I was right.
Okay. All right. Hello. Come back to me.
Argument is over. I didn't get that.
It's literally video.
Okay. Now,
Well, then go back
I-
to once. I never heard of it.
I'm going to take this up into the cloud. So this becomes 0.01 over here.
Why? Because we divided the.
So you take 0.02
Right.
divided by 2 is 0.01, and that's how much I ended up with over here. Okay? So now my Kc value is going to equal 0.08, and what do I have to do with that?
You have
Square
to square
it.
it.
Divided by 0.01, and this time you should end up with 0.64.
Wait,
Spoiler.
Wait, what? Oh, yeah.
She is tired.
What about sticky pigs? I don't know. Okay, Lil. I was thinking of Piggy and Sam.
All right. Can you flip your page over to the next section? Okay, so it is 7/8. Okay. All right. Thank you. All right. So how do we represent what's going on in equilibrium?
A big one. No, that's why they're gonna let me switch.
I think I might have to switch seats around in here.
No!
And you guys need to figure something out because you're driving me nuts.
Okay.
You've been warned. Yeah, no, I need to like divide and conquer over here.
Divide.
All right, so just as we've seen here, we can look at these relative numbers of particles. Didn't I just warn you?
We're not talking.
I literally was putting a thing over it. I was saying the zipper lip.
Consider these images here, okay? This is initial equilibrium. We're adding in some extra stuff, and then this is our possible new equilibrium. So when you add stuff in, that's going to change the way that the concentration of the material. Okay, if you added AB in here, and this is the concentration of A, that means that you're going to increase A until you create a new equilibrium, because some of that AB will then form into A and B squared. B is going to do that more rapidly. It's going to gain a higher concentration here. Why would this line be higher than this line? Well, we added the same amount of AB cubed. Why is B2? Why is that line so much higher here?
There's three.
Right. It goes up. It increases at a 3-to-1 ratio. And then your AB will go up right away. Why is it such a steep thing here and such a gradual slope here?
Because they added AB3 in.
Right, they added AB3 in, so it's going to be a straight up line, and then it's going to ease off a little bit as some of that AB3 turns into A and A2, B2. Okay, and that's going to slowly go down. We still got time, right?
10 minutes.
Oh, yeah, that's easy. Okay. All right. Bye, hon. So we're going to count up how many N2s we have here, how many H2s and NH3s. So my N2s are bigger. Did they give us a key on this? Doesn't look like it. But we know that hydrogen and nitrogen are diatomic, so we can identify these as either hydrogen or nitrogen. We also know that hydrogen is much smaller than the nitrogen, and we can look at one of these and realize that the blue one is the nitrogen because it's 1 to 3, and the rest of these are hydrogens. So we're going to count up our nitrogens first. And I always, when I'm doing this on a diagram, I'll typically actually write the numbers of them above here. So 1, 2, 3, 4, 5, 6. And I do that so that I make sure that I don't double count them. Okay. 1, 2, 3, 4, 5, 6 of these. And then down here, we've got 1, 2, 3, 4, 5, 6. It looks like 6 total there as well. All right, go back, double check, make sure that I've got a number on everything. I'm good. Okay, so now I'm going to figure out, we reduced our pressure from here to a liter. So we halved the volume. Now we're going to go back and count. How many nitrogens do I have? 1, 2, 3, 4, 5. Hydrogens, I have 1, 2, 3. Is that it?
Yep.
Okay. And then my NH3s, I've got 1, 2, 3, 4, 5, 6, 7, 8.
She was underestimating me.
I know. Oh, boy.
All right. So, what was the question?
Look, there's no. I like this problem.
Oh, it was already drawn for you. I guess you were supposed to. I should have eliminated those things. I'm sorry.
What are we eliminating?
Wait, what were we supposed to do?
I should have like not had this drawn here. I should have made you guys draw these in.
So how would you have known?
Okay.
6 months.
Oh, but how would you know how?
And the
Yeah.
two
What?
you can check. Oh, from the thing. Because if there's 6 moles of hydrogen, then there's.
Oh.
Wait a second.
Okay.
This is confusing.
All right. Okay.
Oh, I see.
No, you don't.
Yeah, I do.
All right. So there's a little bit of information that I'm going to share with you tomorrow that'll clear how you know these values are what they are. Okay. Now, I need to kind of pick back up on this tomorrow. Okay. This one, though, we should be able to draw knowing this amount, the information up here. Okay. So here we're starting at 6 moles of nitrogen, 6 moles of hydrogen, and 6 moles of ammonia at equilibrium. We've got a 2 liter container. How much of each reactant will change if the volume was reduced to 1 liter? So again, I don't know. Okay, so tonight you're just going to do 7, 7. Okay. I got to talk to you about how to know about these, and I don't want to try to start that today. It's just going to get messy. Okay. Practice your French tonight. You need to be able to say Le Chatelier. Le Chatelier. There you go.
I thought you just put gibberish.
You used to do this.
And
Yeah,
you're like smoking yourself?
Yes.
Yes.
I have blood. I have blood in my hand by like that.
I did, but
Right.
Holy smokes. What is it? Monday, January 24th.
holy smokes.
Keep up that. January?
I need like,
I think it was on
February,
February.
no. No, I just know.
So long.
I need like a horn.
Do you think Miller will let us bring feet in our
Go back, go around.
Miller will let us
They think that's,
I think it's too much time.
What? It's so random. I want to see. Not affiliated with Big Eight. Oh my gosh. Corona boys basketball.
So when is your game tonight?
No, there's Friday. We have one tomorrow.